A very good morning to all. I'm Dr. Subashini, professor in Department of Information Technology from Beltech Multitech Dr. Rangarajan, Dr. Shakuntala Engineering College. In today's video, I'm going to deliver a lecture on transport layer protocols. Two major transport layer protocols are TCP and UDP. First, let me discuss about transmission control protocol, which is TCP, and then I'll move on to UDP. So transmission control protocol, it is a connection-oriented, it provides a connection-oriented service and also a reliable service. So connection-oriented service means when a client or the server wants to transfer the data, first it has to establish a connection and the data transfer can happen next, followed by, and once the data transfer is over, they have to terminate the connection. So this is what happens in TCP. And this TCP provides a reliable service. Since it is a connection-oriented service, TCP provides a reliability means the probability of failure. So the loss of data must be less. So since it is a connection-oriented service, it ensures that the failure is less. And even if failure occurs, TCP tries to recover the data, and it tries to retransmit the data. And the another important service which TCP provides is process-to-process communication. As you know very well, the transport layer protocol ensures process-to-process communication. So you have consider on the client side, you have n number of applications or the process running on the client side, and you have n number of applications running on the server side. One such application is FTP, where the client wants to make some request for a file from the server. So the server is also running an FTP. So now the client makes a request, and this request have to be forwarded to the application, FTP application, which is running on the server side. So how does this request correctly reaches the application? So as I told you before, you have n number of applications running on the server side. So this request which the client sends has to properly reach the destination FTP application, which means the server application. And this happens using the port number. So using the port number only, the data which is being forwarded to the FTP on the server side is correctly forwarded to the FTP FTP process. Okay, so this is how the data is being transferred correctly to the respective application, and that is why this TCP ensures process-to-process communication. And TCP ensures a stream delivery of service. So all the data is transmitted as bytes, and the receiver also receives in the form of bytes. First, let us see the TCP segment format. So TCP consists of a header portion. TCP segment consists of a header portion and as well as a data portion. The header portion is around 20 to 60 bytes, and the data portion, the maximum TCP segment size is 536 bytes in case of IPv4, and it is 1220 bytes in case of IPv6. So as I told you, that the header occupies maximum of 60 bytes. The rest will be the data portion. So let us discuss in detail about the header format of the TCP segment. You have first one is the 16 bits is of source port address, and you have the destination port address. So as I told you, since TCP ensures process-to-process communication, so you have to send the sender's port address and the destination's port address. So that is what it will be present in these two fields, followed by the sequence number. So each and every byte is numbered so that on the receiver side, these bytes can be ordered without any misordering. All the bytes will be received on the receiver side in a proper order. So for that only we have a sequence number, and you have the next field is a acknowledgement number. So acknowledgement number for each and every data, as I told you, it ensures a reliable service, right? So whatever data it is being transferred to the other machine, or when the client sends some request to the server, that once the server receives the request, it has to properly acknowledge to the request sent by the client, then only the client can make sure that the information which it has transferred has properly reached the destination. Okay. So for that purpose, we make use of the acknowledgement lemma. Similarly, the client should also acknowledge the data which is being sent by the server. So for that, they make use of this acknowledgement number. And HLen, it stands for header length. So it gives you the length of the header. And next is 6 bits is reserved. And you have 6 flags. So first URG flag, urgent flag, and acknowledgement flags again. And next one is push flag. And next one is a reset flag. Next SYN stands synchronization flag. And next one is a fin flag. And so you have 6 flags. Okay, this 6 flags ensure a proper and a reliable communication. I'll just explain all these 6 flags and then move on to window size. So these 6 flags, first one is, as I told you earlier, this is a urgent flag. So you have a stream of bytes which is being transferred from the client to the server or server between two machines, two applications to process. If you want to make a few bytes, few data to be sent very urgently, in that case, you have to enable this urge flag. Okay. And then how many bytes have to be considered as an urgent data, that has to be mentioned in the urgent pointer. So you have a field which is known as urgent pointer here. So you have to mention till which byte you have to consider the bytes as an urgent data, which has to be sent immediately without any, we should not hold it, the process, and it should not be put in a buffer. Why? Because that particular data has to be transferred immediately. So in that case, this urge flag have to be enabled as one and followed by the acknowledgement. So as I told you earlier, for each and every thing, the client should acknowledge the server and server should also acknowledge. If that segment is going to be an acknowledgement segment, then this flag has to be enabled, followed by the push flag. So now the data has reached the destination. For example, it has reached a server, and this has to be pushed to the respective application process. So what happens is that whatever data the client sends, it will be put in the buffer on the receiver side, on the server side. So now from the server, the data has to be pushed to the application. So if you enable this flag, the data, that particular byte will not be, data will not be kept in the buffer. Immediately, it will be pushed to the application process. So this is what push flag is meant for. And RST, which is reset, it is meant to reset the connection. And sync flag, so it is meant for synchronization. So it is meant to synchronize the client and the server. If this is going to be sync bit, this sync flag has to be enabled, and followed by the fin flag. Fin is it stands for finish. If suppose the data transfer is over, then we have to terminate the connection, and for termination, fin segment is being used. And next one is the window size. So window size, this window size, the receiver have to specify. For example, if the window size, if the receiver has mentioned as 1000, it is an information to the client that it has to send only 1000 bytes. Why? Because the receiver can receive only 1000 bytes. So based on the window size, the client has to resize its window. Either it has to shrink it or it has to increase the size of the window based on the window size which the receiver sends. And next one is checksum field. Checksum field, it is meant for error detection. As we told earlier, this TCP is meant for reliable service. So this checksum ensures that the data which has been received is without error, which is error free, so that that particular data can be accepted. And urgent pointer, I've already said. And last one is options and padding. If suppose if there are some bytes which is left free, that can be padded with 0. So this is all about the TCP segment format. And let us move on to TCP connection. So since TCP is meant for connection-oriented service, there are few steps which has to be followed. Once if TCP wants to establish a connection, you have to go with the first phase of connection establishment, followed by data transfer. And once the data transfer is over, the connection has to be terminated. So let us see connection establishment in detail. So TCP ensures a full duplex mode connection. So now let us see the steps in connection establishment. So I'll just explain you with the diagram so that it easily reaches you. The process easily reaches you. So this is on the client side. This is a client process, and this is the client transport layer, which runs on the client side. And you have a server process, which runs on the server side. So the client is the one which can initiate an active open. This passive open means the server can say that it is ready to accept any request. It can just place a request, but that request, that passive open, cannot initiate a connection establishment. So whatever once when the server is free, it can just open a connection which is quite passive. So now it is the client which can initiate an active open. So now the client has to send a sync flag, since the very first segment which the client process sends is the synchronization flag. So we have to enable the sync bit. So we have seen 6 flags, right? TCP contains 6 flags. Out of that, the sync flag has to be enabled. So each and every segment has to be numbered. So this numbering is done randomly. So 8000, it generates, the client generates this sequence number randomly. And now this sync says, once this sync segment reaches the server has to acknowledge it. Okay. So it has to acknowledge the received segment. In addition to that, it should also send the sync flag. The server has to send a sync flag. So this is now piggybacking concept comes into picture. So along with the synchronization, along with the acknowledgement, you try to send, along with the synchronization, we try to send the acknowledgement. So you are piggybacking, you are trying to send both a synchronization and acknowledgement together. So this is a piggybacking concept. And once this reaches the client, the connection is opened up, and this client has to acknowledge the synchronization segment which is being sent by the server. So now the client sends an acknowledgement. It is not only that the client now can send only an acknowledgement. Along with that, if it has few bytes of data to be transferred, that can also be sent along with the acknowledgement. So this is how connection establishment happens, and followed by the data transfer. Once a connection has been established, the client and the server can start to transfer the data. So the sender, if it wants to place a request, it can place a request. So see here, I've enabled the acknowledgement, and I've also enabled push. Okay. So here, as I told you, push on the server side, it has to be immediately pushed to the application process. So for that, I've enabled this one. This has been enabled. So once the server receives the data, it has to send an acknowledgement. And if it wants to send any data along with the acknowledgement, it can send the data. So that is what. So each and every segment has to be properly numbered. That is why this sequence number holds a sequence number of each and every segment. So this is how it holds. So 15,001 and to 17,000. Okay, so this is the stream of bytes which the server is sending. Okay, so the sequence number always it points to the first byte which the application sends. So it's this segment starts with the sequence byte number 15,001. So your sequence number is going to be 15,001. So this will be acknowledged by the client, and this is how the data transfer goes in TCP. So once all the data has been transferred, so you have to, and it enters into a connection termination. So in this connection termination, the client process, it is a client which initiates an active close. The client has to send a pin segment. A pin segment, actually we have 6 flags. So out of that, the pin flag has to be enabled. Why? Because this segment is going to be the finish segment. So once the server receives a finish segment, so it has to acknowledge. So if it has some data to transfer, once all the transfer has happened, it has to send the finish segment, and along with that, it can send an acknowledgement of the client. And once the client reaches the acknowledgement finish segment from the server, it again has to acknowledge. This is an acknowledgement for the finish segment, which has been sent by the server. And once the acknowledgement receives the server, the connection will be terminated. So this is how the connection oriented service has been provided by the transmission control protocol. So in tomorrow's session, we can see about UDP services and its header format. And we can also see the difference between the TCP and UDP. Thank you.